Hello, ladies and geometry students. In previous assignments, we talked about parallelograms and the relationship between different quadrilaterals, but in today's lesson, we're going to talk about the other quadrilaterals and the rules that apply to them. Now, we already talked about quadrilaterals in general and parallelograms, and we're not going to talk much about kites. The remaining shapes, each of these shapes, each has one or two simple rules that we got to remember that can come up. Most of them are not that difficult and have some really simple uses. For example, let's start with the rectangle because it's the easiest shape. A rectangle is a quadrilateral with four right angles. All four angles are 90 degrees. That's what makes something a rectangle. Now, it's also a parallelogram, so all the rules for a parallelogram still apply to it. But the right angles is the key feature to a rectangle. So a sample problem for using this might look something like this. It tells us this is a rectangle. Okay, that means the angles measure 90 degrees. This angle is 5x. So what would x have to be? Well, we know this angle has to be 90 degrees. So set it equal to 90 degrees and solve for x. If we do that, we'll have something like 5x is equal to 90. We simply divide by 5 and get x is equal to 18. That's one of two rules for a rectangle. The other rule for a rectangle is that the diagonals are congruent to each other. See, in the parallelogram, you can have a long diagonal and a short diagonal. But in a rectangle, the diagonals are the same. In this picture, the blue diagonal and the red diagonal have to be the same. You cannot have a long one and a short one. So if these two are the same and we're asked to solve for x, all we got to do is set them equal to each other and solve for x. So we'd come up with an equation something like this. 9x minus 10 is equal to 6x plus 2. We're going to subtract 6x from both sides, add 10 to both sides, and then divide by the coefficient. We'll end up getting x is equal to 4. Now, this rule actually has some weird applications, an important one, too, for anyone who ever builds almost anything. Basic shape for construction is a rectangle. Houses, walls, furniture, we base it on a rectangle. And in order for this thing to work properly, we need to know if these are right angles. You have a couple different ways you can measure to see if these are right angles, and there's special tools for this, but the easiest way to do it is simply to take out a tape measure. And we know that if it's a rectangle, the diagonals are congruent. So we measure the diagonals. We measure this diagonal, and then we measure this diagonal. If they're the same, then it's a rectangle, and therefore all our angles are 90. If they're not the same, then the angles are not 90. It has to be that way. So it's a kind of a quick and easy way to determine if you got right angles in a shape is to measure the diagonals. Okay, the other shape, the second shape that we're going to talk about is a rhombus. Now, a rhombus has four congruent sides. This one is moving, so you can see that it doesn't really matter how the angles are. We can make them bigger or smaller, or they can end up being the same. But it's the four congruent sides that make this a rhombus. All right, so if all four sides are congruent, a common problem that comes up with a rhombus might look something like this. Here are two sides of the rhombus. Solve for x. Well, we know that these two sides have to be congruent, so we set their measures equal to each other and solve for x. So we'd write an equation, something like 5x minus 8 is equal to 2x plus 1, and then we're simply going to subtract 2x from both sides, add 8 to both sides, and divide by our coefficient. We'll get x is equal to 3. That's the first rule for a rhombus. The second rule is that the diagonals make a right angle. The diagonals are perpendicular. So we have a problem like this, where inside our rhombus, by drawing in the diagonals, we've created a bunch of little triangles. We want to find the measure of one of these angles? No problem. What we have to remember is that the diagonals are perpendicular. Therefore, that has to be a right angle. Now we can just look at this little triangle and be like, oh, you know that this angle plus the 90 plus the other angle have to add to 180. So simply subtract these from 180 to find the missing measure, to find x. Well, in this case, 20 plus x plus 90 is 180. So we simply subtract the measures we know from 180, and we'll get that x is equal to 70. This actually has some interesting uses. The fact that the diagonals in a rhombus are perpendicular allow us to take this shape and make it expand or contract in things like a scissor lift on the right, or a jack, like to lift up a car when you change the tire, over on the left. So this is a summary for all the rules for parallelograms. So generally, a quadrilateral is just a shape with four sides. A parallelogram, which has the most rules, the opposite sides are parallel, the opposite sides are congruent, the opposite angles are congruent, consecutive angles are supplements, and then the one everybody forgets, the diagonals bisect or cut each other in half. And then we have our other shapes. A rectangle has four right angles, and the diagonals are congruent. A rhombus has four congruent sides, and the diagonals make right angles or are perpendicular. And a square doesn't have any new rules. A square is just what happens when you have both the rules for a rectangle and the rules for a rhombus included. So all the rules above here apply for a square, but there's no unique rules to the square. Okay, another way to think about it is like this. All of these shapes on the screen, these are all parallelograms. All of them are parallelograms. But these over here, they all have four sides congruent. So those are rhombuses or rhombi. And over here on the right, these shapes all have right angles. That means those are all rectangles. And the place where they overlap right there in the center, that's a square. Okay, the last shapes we're going to talk about are trapezoids and isosceles trapezoids. Remember, a trapezoid has one set of parallel sides, like these pictures you see up here. And a couple things to know about a trapezoid. It's a little bit of the weird shape. The problems might look something like these. Okay, but here's our trapezoid. First, we got to know a couple of words. The parallel sides we call bases. Those two sides, the top and the bottom in this case, that are parallel to each other are the bases. The other two sides are called the legs. So the parallel sides are the bases. The other sides, the non-parallel sides, are the legs. Now, with the trapezoid, the rules, we have two rules. They're a little bit weirder. One of them is that the same side interior angles are supplements. In other words, if we see a picture like this, it's actually really easy to figure out what X and Y are. And let's just focus over here on the right. These two angles, the 83 and the X, they're supplementary. They have to add to 180. Why? Well, because of these parallel lines. If we took half this picture away and just looked at this is just part of the picture from first semester where we had parallel lines and a transversal. And if we knew the measure of one angle, we could find the measures of all these different angles. And every angle in this picture is either the same or adds to 180. They are either congruent or supplements to the original angle. So this 83 here, well, and this angle up here, these two are going to have to add to 180. So to find X, we just do 180 minus 83. And in that case, we're going to get 97 degrees. We do the same thing on the left. Now the angles on the other side, connecting the two parallel lines, these two angles also have to be supplementary. They have to add to 180, but they don't have to be the same measures as the ones on the right. These are going to be different measures. So these two angles also add to 180. So to find Y, we just do 180 minus 65, and we'll get 115. The other thing, so we're going to take a second and try a couple of problems. Find A, B, C, and D in these pictures. You'll notice in the parallelogram on the left, the picture is turned sideways, so you have to maybe turn your head or just imagine this thing turned the other way. But the 70 and the A, these have to add to 180. So to find A, we just do 180 minus 70. We get 110. To find B, these two angles here have to add to 180. So we just do 180 minus 90, and we get 90 for that one. Over here in the trapezoid on the right, for angle C, the angle C and the 50 have to add to 180. So angle C is 130. And on the right side, the 115 and D have to add to 180. So D is 65. Okay, the weird thing in a trapezoid is the mid-segment. The mid-segment is a line through the middle of the trapezoid that's parallel to the bases, and it's exactly through the middle. That's the key thing here. So here's our trapezoid. We got our two parallel lines. If we draw a third parallel line right in the middle so that each side is cut in half, or so that we are connecting the midpoints of the sides, if you think about it that way, this is called the mid-segment. The mid-segment will be important a little bit later when we talk about area of shapes. But to find the mid-segment, it's simply the average of our two bases. So if the short base on top is 10 and the long base on bottom is 20, the mid-segment is going to be halfway between them. So you simply take the average or figure out in some way what the number halfway between these two are. The technical way to do it, add them up and divide by 2. 10 plus 20 is 30. Divide by 2, we get 15. Or 15 is halfway between 10 and 20. That's the length of the mid-segment. All right, so in each of these problems, find the length of the mid-segment for the trapezoid shown. In the first picture, we do 8 plus 12, that's 20. Divide by 2, we get 10 for the length of the mid-segment. In the second problem, we're going to add up 48 and 66. That is 114. And divide by 2, we'll get 57 for the mid-segment. The last problem, 12 plus 28. Add those two up. That's 40. And divide by 2, we'll get 20 for the mid-segment. All right, the last thing we're going to talk about is an isosceles trapezoid. And an isosceles trapezoid is just what happens when the two legs in the trapezoid actually are the same. So end up like the left side and the right side are the same. And basically, this is just like an isosceles triangle. The angles on the left side and right side will match each other. And that's basically it for an isosceles trapezoid. These two angles will be the same, and therefore these other two angles will be the same as well. So an isosceles trapezoid is just like an isosceles triangle. So if we know the measure of one angle, say this angle here is 70 degrees, we can find the measures of all three of these other angles. The one on the bottom left here is also going to be 70 because it's isosceles. And then these angles up here, well, this is whatever I add to 70 to get 180 in the upper right. And in the upper left, this is whatever we add to 70 to get 180. So we'll find both of them, they'll both turn out to be the same. They're both going to be 110 degrees. So take a minute in this problem. This is an isosceles trapezoid. Find W, X, Y, and Z. All right, in this case, the easiest one to find is W, the sides. We got the little tick mark saying here. So the right side is 20. It's isosceles. So the left side is going to be 20. So W is going to be 20. Then going in and finding the angles. 80 is this bottom right angle. The matching angle over here, since it's isosceles, is going to be X. So this one is also going to be 80. And then finding Y and Z, well, since it's isosceles, they'll both be the same. And they're both going to turn out to be 100 degrees.